Okay, problem number 1, 6 over 7 times 14 over 3. The first thing I would do is reduce the fractions before I multiply. 6 over 3 reduces to 2 over 1. 14 over 7 reduces to 2 over 1 as well. And so when we multiply, we get 4 over 1. So the answer here would be B. If you decided not to multiply, or not to reduce, before you multiply, then 6 times 14 would give you 84. 7 times 3 would give you 21. Those are pretty big numbers. You'd have to reduce it anyway. So you divide both sides by 21, or both top and bottom. So you would get 4 over 1, and the answer would still be B. But the top method is obviously much easier. In problem number 2, we need to solve an equation that has fractions. The best way to do that is to do a strategy called clearing the denominator. So if you look at all of the fractions, we have 3 and 6, and of course we have whole numbers that have a denominator of 1. So we multiply everything by 6, which is the least common denominator of 3, 6, and 1. So when we distribute, we would get 6 times 2 over 3, which is 12 over 3, which is 4x minus 6. 6 times 1 over 6 is 1x plus 24. This becomes a much easier equation to solve. Subtract 1x from both sides, so that gives me 3x minus 6 equals 24. Add 6 to both sides. That then gives me 3x equals 30. Divides both sides by 3. So our answer is x equals 10. Okay, in problem number 3, we have to look for which one of these graphs is totally vertical and has a negative x-intercept. Before we look at the right answers, let's look at the wrong answers. Y equals negative 4. That's a horizontal line, so we go 4 spaces down on the y-intercept. And so that'd be a horizontal line right here. That's y equals negative 4. We can see that there is no x-intercept, and we can see that it's not vertical. Y equals negative x minus 2. So the y-intercept here would be negative 2, and the slope would be negative 1. So this graph would look like this. This would be y equals negative x minus 2. We can see there is a negative x-intercept, but we can see that it's not vertical. If we look at the next one, x equals negative 4y, divide both sides by negative 4, so we'll get negative 1/4 x equals y. So the y-intercept is 0, and then the slope is negative 1 over 4. So this graph looks like this. You can see it's not vertical, and the x-intercept is not negative. The x-intercept is actually 0. So now looking at the right answer, x equals negative 5. We can see that the x-intercept would be negative 5. And x is always negative 5. So you can see that this would be the right answer. X-intercept of negative 5, vertical line. Problem number 4, we have to solve for x and then substitute. So if we have x over 4 equals 6, we clear the denominator by multiplying both sides by 4, and then we would get x equals 24. Then we substitute into x over 8. X over 8 would then be 24 over 8, which would be 3. So the answer here would be A. Another way to do it is if we say x over 4 equals 6, we could multiply both sides by 1/2. And if you multiplied by both sides by 1/2, you would get x over 8 equals 3, which is the same answer. In problem 5, we have a graph, and we're asked to find the relationship between mass and volume. So we have mass here and volume here. Typically, on a graph, this would be the y-axis and this would be the x-axis, but instead we have m and v. The first thing we do is we notice it's a line, and so if we wanted to find the slope of the line, we'd kind of pick 2 points. You could pick any 2 points, but 2 easy ones would be 0, 0 and 2, 6. Now normally, the slope of a line between 2 points would be y2 minus y1 over x2 minus x1. But in this case, since we have m and v, we would then do m2 minus m1 minus v2 minus v1. In other words, the y coordinate, which would be 6 minus 0, over 2 minus 0, which would then give me 3 over 1, or just 3. We also know that the slope-intercept form of a line is y equals mx plus b, and we know the y-intercept is 0 since it passes through 0, 0. So the equation of the line would basically be y equals 3x, but using it in terms of m and v, that would give me m equals 3v. So the answer here would be B. Okay, problem 6, we have to find the median of the set of numbers. When you find the median, you have to make sure that they are ordered from least to greatest, which in this case they already are, so we don't really need to change anything. Then we just kind of strike out numbers from the outside in to find the middle number. So we cross out 2 and 16, cross out 5 and 12, and you realize that we have two numbers in the middle, 7 and 9. So if you only had one number in the middle, that would be the median. But since we have two, we take the average of those two numbers, add them up, and divide by 2. So we get 16 over 2, which would be 8. So the answer to number 6 would be B. Okay, this problem is pretty tricky. We have 3 teaspoons in a tablespoon, and we have 16 tablespoons in a cup. And we're asking what's going on with 12 teaspoons. So we have to do a double conversion here. So we know that there are 3 teaspoons in 1 tablespoon. And you know that we have 12 teaspoons. So the first thing we're going to do is we're going to figure out how many tablespoons that is. So we can cross multiply. That'll give me 3x equals 12. And then we divide by 3. So that means x equals 4 tablespoons. So then we look at our second equation here. And so we have 16 tablespoons, which is in 1 cup. And we've already made this conversion of the 4 tablespoons. And we want to know how many cups that is. Let's use a different variable. Let's use y. So cross multiply again. That'll give me 16y equals 4. Divide both sides by 16, so that gives me y equals 1/4 of a cup. So the answer here would be B. A little bit tricky here, but you'll have to do 2 conversions. Okay, problem number 8. We know that the total calories of a salad are 1,100, and the salad contains cheese, vegetables, and dressing. So we know that 1,100 is equal to the calories in cheese plus vegetables plus dressing. We're also told that the value of cheese and vegetables is 650. So we can just replace the C plus V with 650. And we know each packet of dressing has 75 calories. So we're just going to write plus 75x, where x is the number of calories in each dressing. So we just solve it, minus 650 from both sides. That would give me 450 equals 75x. Divide both sides by 75, and you should get x equals 6. So that means there were 6 packets of dressing in this salad. Okay, problem 9, I have x squared over 6 equals x over 2. So I might cross multiply to begin. So that would give me 2x squared equals 6x. I could divide both sides by x. So that would give me 2x equals 6. Divide both sides by 2. So x equals 3. Here would be the answer. Another way to kind of look at this problem is just to use common sense. If you substituted 0 here, you would have 0 squared over 6 equals 0 over 2. So obviously 0 equals 0. So there's actually 2 answers that would be acceptable, 3 or 0. Okay, problem 10, we have the price of an item, which is $P, but then we are given a 30% discount. And so we want to figure out what the discounted price or the final price is. So this is pretty easy. We just have to take the original price, which is P, and we have to subtract the discount, which would be 0.30p, and that would give me the final price. So just remember that P represents the original price, and this represents the discount. So this would be the same thing as 1p minus 0.3p, which is the same thing as 0.7p, and that would be our final price. So the answer here would be C. In number 11, we're given an equation representing the gravitational force, and r is the distance between the objects. And we're asked what happens if everything stays the same, but the distance between the objects doubles. So if we think about it, we have the original, which is g times m1, m2 over r squared. But then we double r, or double the distance, so that would be g m1, m2. Instead of writing r squared, I'm going to write 2r squared because we've doubled the distance. So if we work this out, this becomes g m1, m2 over 4r squared. And we want to ask ourselves, what's the difference between this one, the original, and the second one? And you can see the difference is we've multiplied by 1/4 because there's a 4 in the denominator of the doubled distance versus the original. So the answer here would be D. It would be 1/4 of the original force.